It's one of the great engineering feats of the 20th century, the Hoover Dam. 726 feet high, weighing 6.6 million tons. The dam's 17 generators produce nearly 3 million horsepower of electricity. Electricity created using a magnetic field. Scientists had figured out how to create magnetism with electricity by running an electric current through loops of wire. The result is an electromagnet. Turn on the electric current and a magnetic field is created. Turn off the current and the magnetic field disappears. In 1831, a bookbinder with an interest in electricity named Michael Faraday was first able to reverse the process using a moving magnetic field to create electricity. An electric generator in its most basic form is just a coil of wire between the poles of a magnet. Michael Faraday discovered that when the magnet and the wire move near each other, an electric current passes through the wire. Every electrical generator works on this simple principle. Faraday kept somewhat cryptic notes on his experiments, but years later they proved invaluable to a physicist named James Clerk Maxwell, who used them to contribute to our understanding of how electromagnetism works. To find out more about this discovery, I paid a visit to the Museum of Science in Boston.
Bill Nye, this is great. So what is this device?
Well, this is a generator, and we use it here at the museum to talk about lightning and lightning safety, and a little bit of what you were just mentioning, that sort of connection between electricity and magnetism. We've got this demonstration, this sort of giant bird cage, and we can use that to show how electricity and magnetism are sort of interrelated. Would you like to try it?
Well, yes, of course.
Well,
one test is worth 1,000 expert opinions.
After you.
One of the things Maxwell helped us understand is how electromagnetic fields are distributed on a conducting surface, like the metal this cage is made of.
And now, if you want, when I start to make some of the sparks, if you put your finger on the inside of that bar, you should be okay. If you want to give it a try.
If Maxwell was right, the enormous 1.5 million volts of electricity created by these generators will distribute itself nicely around the outside of the cage and not be able to penetrate the inside. Right now, I'm hoping James Clerk Maxwell was right.
You ready?
Yeah.
Well, go ahead, put your finger up there and we'll give it a try. Here we go.
It is spectacular. So what's happening, the electricity is hitting the cage, and that's creating a magnetic field?
That lightning bolt is a current of electricity. It strikes the cage, and that turns the entire cage into sort of a giant magnet. The magnet, in turn, makes another electric field. And that electric field around the outside of the cage pushes all the electrical current to the very outermost surface.
Yeah, it's amazing. Well, thank you very much.
Well, thanks for coming.
I'll never forget that. That is just spectacular. I'm fine. If you want to know what the world would be like without the work of Faraday and Maxwell, imagine a world with no electricity. There'd be no radios, no television, no cell phones, no satellites, no modern communication of any kind, no computers. Think of being in the 19th century. That's where you'd be. Now, what Faraday and Maxwell couldn't know was that their discoveries would inspire a young man who would go on to unlock the secrets of light and its connection to a fearsome power in the universe.